Okay, as you prepare to take notes for this one, I would suggest that you write small or plan to attach another sheet. As you can see, there are multiple steps to this one, but it gives you kind of a lot of different options that are going on with this one. So I'm using acetic acid, a very common acid system, with a Ka value of 1.8 times 10 to the negative fifth. And again, you don't need to know those. Those have to be given to you, but this one you might actually start knowing just because I've done so many examples with that. So 1.8 times 10 to the negative fifth. So initially, for part A, you only have acetic acid present. So you're going to have the HA. I'm just going to abbreviate that because you know you've been writing a lot. H plus A minus, and again we could do that fancier with hydronium and water, but just for brevity's sake on this one I'm going to abbreviate that one. So if I have 0.1 molar acid here, I have 0 for both of these. I'm going to subtract X, add X to both of these. X is going to be negligible for this one because the exponent is so small, and then you're going to have X in this. So you're going to have, for your Ka, X squared over 0.1 equals 1.8 times 10 to the negative fifth. And when you solve for that, you get X is equal to 0.0013, and taking the negative log of that gives you 2.87 to 2.89, depending on how far you round out there, but depends where you keep all your digits. So as long as you're close to that, that's fine. So for part B, we're going to be looking at some stoichiometry. So the NaOH is going to react with the acetic acid. Okay, A minus will be your acetate ion. So at 10 milliliters of this and 50 milliliters of this, we're going to have to count for all those volumes. So 50 times 0.1 and 10 times 0.1. So this is going to give you 5 millimoles and 1 millimole. And again, we're using that little shortcut with millimoles, and you can see in this problem why that's going to be. So hydroxide is your limiting reagent, so minus 1 is going to give you 0, minus 1 here is going to give you 4. And this was initially 0, so we're going to add 1, so we're going to have 1 millimole here. And here's where you're going to love that equation. Again, I'm going to be using that frequently. So we know a buffer system since we have the acid and base. And again, if I take the pKa, which is the negative log of that 1.8 times 10 to the negative fifth, that is going to give me that 4.74. You saw that in some other questions. Okay, my base is the A minus. So I have 1 millimole of that divided by my total volume now is 60 because I have 60 milliliters. Because I have 10 initial divided by my 4 millimoles over 60 milliliters. Again, 10 plus 50 is giving me my total volume of 60. So each time we go here, we're going to add those together. Okay. And when we calculate that, we get 4.14. Okay, and that makes sense because I have more acid than I do base. So again, always kind of check, does your answer make sense for what you're doing? Okay, the next frame you're going to see the questions disappear, so you're going to have to just kind of keep referring back to your worksheet for that. So we're going to start on part C. We're always going to come back to sort of where we started with this. So we started initially with 5 millimoles, so we're going to pretend like this is starting over the beginning with this. Now, at this point at C, we have 25 times 10. So this is going to be 2.5 millimoles. And again, assuming we have none of this. So we're always going to kind of begin with stoichiometry all over again. So hydroxide is still my limiting. So I'll have 0 of that and 2.5 millimoles. Again, important to note, I don't imagine they do this to you in the exam, but this is a 1-to-1 ratio, so you do always have to think about that. We have had a couple where you had factors of 2 times that. So that would give us a total of 2.5 millimoles. So again, plugging in my pH equals my 4.74 plus the log of, now notice these are all going to cancel out, but for the AP exam, if you don't show the molarity that you're using molarity and you just use moles, they will not give you credit for that. So this we have the 25 milliliters that we've added plus the original 50, so this is over 75 milliliters. And that's all just your A values. I'm going to do a little longer line. And then you're going to have 2.5 over 75 on the bottom. So we have millimoles for this, milliliters for this. So you'll see how your millis cancel out, so that's why that's molarity. So the log of that whole thing is going to be 0. So this is your buffer zone where you have exactly the same moles of acid as you do base. So this will be 4.74 as your pH. So we go on to D. So again, looking like 5 millimoles of this. So this time for D, we have 40 milliliters, so 40 times my 0.1 is my 4 millimoles. Again, hopefully you're seeing a pattern here. So minus 4, minus 4. So 1 millimole, and this would be plus 4 millimoles. So we know to do our pH, it equals 4.74 plus the log of what our base is 4 millimoles over our total volume now, which is our original 50 plus 40, which is 90 milliliters over 1 millimole over 90 milliliters. Now when you calculate these, you certainly can cancel out the 90s. That does make your math a little easier, but you do need to show that. I just can't emphasize that enough, that you show that it's molarities in this, or this equilibrium equation, in any equilibrium equation. So, and now we should have a pH of 5.35. So notice our pH is going up. So Again, jumped 1 whole unit, so this is showing that we're getting closer to that equivalence point. For section E, again, same thing. We're doing stoichiometry first. So my original 5 millimoles, 50 times 0.1 is 5 millimoles. So this is my equivalence point. I've gotten nothing on these, and a total of 5 millimoles here. So we now have another equilibrium. So this is the the base equilibrium. Notice we now have hydroxide. So, and this is going to be your Kb. So 1 times 10 to the minus 14th over 8 times 10 to the negative 5th. Which is going to be 5.6 times 10 to the negative 10. So we're going to have 5 millimoles over 100 milliliters. 0 of each of these, again minus x plus x and plus x. So we set this into your equilibrium. Your Kb value equals x squared plus over 0.05, and that's coming from simplifying this. When we simplify that, x is going to be 5.36, or excuse me, 5.3 times 10 to the negative 6. And this time, that is an OH concentration. So we're going to get POH equal to 14 minus 5.28. Oh, sorry, that's pH. So POH is the 5.28. And 14 minus 5.28 gives us 8.72. And again, makes sense that this should be basic because we have an excess of hydroxide. Okay, and after we're going to see a little bit of a switch. At this point now the acid is the limiting, so we're going to have an excess of base. Oops, sorry, this should be G. No, I lied, it is F. So 6 minus my 5 millimoles is going to give me 1 millimole of hydroxide and 5 millimoles of my base. Okay, this time we're in 110 milliliters. So this is a weak base, and this value is going to be small in comparison. So if we do put this in the 1.8 times 10 to the negative, or sorry, the Kb, which is 5.3 times 10 to the, no, I like 5.6 times 10 to the negative 10. This is going to be very insignificant. So this is the main factor that is doing your pH. So this OH concentration is going to give you 9.1 times 10 to the negative third, and that's a pOH of